Welcome. This would be the very first video, in other words, the introductory video to the topic of colligative properties. And this is a very, very important topic and has a lot of practical applications, and in combinations with gas laws that we just finished, these two topics have so much practical applications that it's hard to overlook them. So understanding it, maybe not entirely mathematically, but at least understanding these two topics conceptually can really have you look at science from a different perspective. I personally think colligative property is one of my favorite topics to teach or to learn because it just has a lot of practical applications. So there you go. I put on 4 things. Each of it has its own unique application or perspective on why it's important. Why can't we put sugar or flour on a road to de-ice it? Why do we need salt? It's a de-icer. And then what makes something boil? What is a component that actually makes a substance boil? Does all substance in the world boil at the same temperature? Does adding something to, say, a solvent like water, how does it affect the boiling point? So a perfectly healthy red blood cell is the one in the middle, which is isotonic. There's hypertonic cells and then the hypotonic cells. Neither of them are good. Okay. What chemical property controls that? It's called osmosis. There's a pressure associated with it, and that's called osmotic pressure. We're going to learn that. And I've already left you with a clue earlier. How does the cooking process is affected at higher altitudes, say maybe Denver or places that are way above sea level? So all of these questions could be answered at the end of learning colligative properties, which makes colligative properties such an important concept. Okay. What does it actually mean? Well, this is the actual definition. What it really means is colligative property depends on molality. Remember that? Molality versus molality. Molality of a substance, which is moles of solute over a kilogram of solvent. But there's something very important in this is it says it's a ratio of number of solute particles to the number of solvent molecules. So it's solute versus solvent. It's not solute versus solution, even though we would answer some questions pertaining to solution. But we're really interested in the solute and the solvent as it is, even though we would use that information to explain how it affects a solution. The number is the key word there. It's not necessarily the word ratio, it's actually the word number. Ratio of number of solute particles to number of solvent molecules. I don't want to dwell around this definition for half an hour, and because it's not going to go anywhere until we actually do some things. So there are primarily 4 different colligative properties that we're going to learn. One is lowering of vapor pressure, which I want to express it as a separate concept, even though that is actually related to all of the other 3 as well. And then elevation of boiling point, depression of freezing point, and then osmotic pressure. If you don't really understand what is vapor pressure, then you really will not have any appreciation for boiling point, nor have any appreciation for freezing point, nor have, maybe not osmotic pressure, but definitely these 2 concepts directly use the idea of vapor pressure. So we will spend a video just on understanding and define what vapor pressure is, maybe work out a problem relating to Raoult's law, and then go on to explain the idea we learned on vapor pressure to learn about boiling point, freezing point, and osmotic pressure. And you see that the word elevation and depression are there. They're there for a reason, and we would account for that through our mathematical problems. And that's all I want to say on this video. So colligative properties is such an important concept. Learning it is not going to ever make you think, why did I ever learn this concept? Or the common question, how does this even matter to what I'm going to do? It certainly does. Okay, so I will try to make it as simple as possible, as concise as possible. So I don't think all of this would take much time. And I personally think not only is this topic more practical, but I think it's also easier from a test perspective. I think most of you will not get most of these questions wrong, except for there's a couple of concepts that involves a lot more algebra where things might slow some of you down, but I personally think this is an easier concept. So stay tuned for the 4 topics that is listed on the screen.